Hello everyone, this is Hw6 and let's talk about homework 6 question 1. X and Y have joint density function and the small fxy equals to 1 at x times y divided by a, and the absolute value of x is smaller than 1 and the absolute value of y is smaller than 1, and the joint density function is 0, 1, xy takes other values. And the first question is to find A, so that the above defined is a valid joint density function. Here we can see to let fxy be a valid joint density function, we have this equation, and this is equals to 1 because the absolute value of x is smaller than 1 and the absolute value of y is smaller than 1, so we can get the upper bound and lower bound. Here we get a equals to 4. And second question is x, y uncorrelated. Here we need to calculate the exy, and this is xy plus times f small fxy dx dy, and we got the answer is 1 divided by 9, and ex equals to this equation, and we got 0 and the same answer of ey, because exy does not equals to ex times ey, so xy are not uncorrelated. And the third question is, are xy independent? Because we can get xy are not uncorrelated, so we know xy are not independent. And the fourth question is to find joint density function of x to the power of 2 and y to the power of 2. Here we set z equals to x to the power of 2, omega w equals to y to the power of 2, and we get the Jacobi. It's 4 times x times y. And from this equation we can get there are 4 roots because xy is the absolute value is smaller than 1, so when z greater than 0, smaller than 1, and w smaller than 1, greater than 0, we can get the absolute Jacobi of 4 times the square of z times square of w, based on the fundamental theorem. We got this equation here. This is the answer. And when z and w takes other values, the small f zw equals to 0, and based on the definition, small f of z equals to this is FZW, and this is then we got the equation. Oh, here we need to add TW. And the same method for FWW, and we got 1 divided by 2 times square of W, because FZW equals to FZ times FW, so x to the power of 2 and y to the power of 2 are independent.